So in this video you are going to be learning about subtracting fractions. The good news is we're going to be still dealing with positive fractions, so you're always going to be taking away a smaller amount from a larger amount, so it's never going to result in a negative. There will be a couple of examples where you're going to have to borrow, and hopefully through this video you will either learn or relearn. So just like adding fractions, you're going to need a common denominator in order to subtract fractions. It's ideal to get the least common multiple to find the common denominator, but again, if you just find a common multiple, that's fine. So in the case of your denominator being 6 and one denominator being 3, I'm going with my least common multiple of 6, which makes my equivalent fraction to 5/6. And then to convert 2/3 into 1/6, again I say 3 times 2 is 6, so 2 times 2 is 4. Now since I have both in 1/6, I rewrite the denominator and I subtract the numerator. In this case, just like all the cases in this video, your second numerator, will be a smaller numerator unless it's a borrowing problem, but nothing will end up in negatives. So here we have mixed numbers. Again, you're going to convert your fractions to equivalent fractions with common denominators. For my least common multiple of 5 and 2, I'm going with 10. I multiply 5 by 2, so I'm going to multiply 4 by 2. I'm going to rewrite my whole number of 3. I'm going to do the same. So I'm going to multiply 2 by 5 to get 10 and 1 by 5 to get 5. So 5/10 is equivalent to 1/2. I'm going to rewrite my 1, and now I'm going to subtract. 8 minus 5 is 3. And 3 minus 1 is 2. So 3 and 4/5 minus 1 and 1/2 is 2 and 3/10. And that should make sense because 3 and 4/5 is about 3.8. And 1 1/2 is about 1.5. And 3.8 minus 1.5 gives us 2.3, which is 2 and 3/10. This should look very familiar. It should look almost identical to the last problem, except now instead of 4/5, which was the last problem, we have 1/5, but we still have fifths and halves, so we're going to convert those to tenths for a common denominator. I'm going to multiply 5 by 2 to get 10, and therefore I'm going to multiply 1 by 2 to get 2, so 3 and 1/5 is going to be equivalent to 3 and 2/10. 1 1/2 is going to be like the same. On the last problem, I'm going to multiply both by 5. I'm going to get 5/10. And now you should notice that when you compare your numerators, 5 is larger than 2. So you can't take 5 away from 2. The good news, however, is that 3 is larger than 1. So you are taking a smaller amount, 1 and 5/10, away from a larger amount, 3 and 2/10. So you can do that. You just have to rewrite 3 and 2/10 to be an equivalent fraction. We're going to do this by borrowing. So I'm going to rewrite my 3 and 2/10 down here. And I'm going to tell you to take one whole away. Well, when I take one whole away, that means I have some whole number floating around. So because in this case my denominator is tenths, and I borrowed 1, 1 equals 10/10. So if 1 equals 10/10, that means 3 and 2/10 is the same as 2 and 12/10. Because I took the 10/10 and I added 10 to 2, that's a plus sign, and I got 12. So 3 and 2/10 is the same as 2 and 12/10. And 2 and 12/10, if I replace that with 3 and 2/10, allows me to take away now. I couldn't take 5 away from 2, but I could take 5 away from 12. So 12 minus 5 is 7. 2 minus 1 is 1. So I get 1 and 7/10. First, I'm not going to know it's a borrowing problem unless I convert, so I'm going to go ahead and do equivalent fractions. I'm going to pick 6 as my denominator. Makes it really easy. So 2 and 5/6 stays 2 and 5/6. Then here I multiply by 2. And I get 5 and 2/6. I know it's a borrowing problem because 5 is a bigger number than 2. Okay, and because 5 is a bigger number than 2, I can't take away 5 from 2. But what I can do is rewrite 5 and 2/6 by borrowing. So I'm going to take one whole away. So it's going to be 4. But that one whole that I took away is going to be equal to 6/6. So I'm going to take these 6/6 I'm going to add them to these 2/6, then I'm going to get 8/6. So 5 and 2/6 is equivalent to, it's the same darn thing as 4 and 8/6. But by writing it as 4 and 8/6, I can now take away 2 and 5/6, because 8 minus 5 is 3, 6, and 4 minus 2 is 2, so I get 2 and 3/6, which I then reduce to 2 and 1/2. So here's a problem where you're taking 1 and 5/6 away from 4. Okay, 4 doesn't have a fraction, but it could. Again, if I borrowed 1 from 4, okay, and I'm going to use 6 in this case because my denominator is already 6, so there's no point in using any other denominator but 6. So I'm going to say 1 equals 6/6. So 4 is going to be the same as 3 and 6/6. So now I can take 5 away from 6, and I can take 3 away from 1. Sorry, 1 away from 3. And I get 2 and 1/6.